So good afternoon everyone. Our assigned topic is all about adjustable measuring tools. So today, I'm going to report about our assigned topic, which is the vernier caliper. Objectives for this lesson: familiarize the different types of vernier caliper. To be able to know how to read a metric vernier caliper. To be able to get the accurate reading of the vernier caliper. Different types of vernier caliper. The first one is flat edge vernier caliper. This type of vernier is used for normal functions. We can take outer measurement of a job's length, breadth, thickness, and diameter, etc. As the jib of its edge is of a special type, the inner measurement can also be taken with it. But from that measurement, the job's breadth has to be subtracted. This measurement is often written on the jaw, otherwise it should be measured with a micrometer. The next one is knife edge vernier caliper. The edge of this vernier caliper is like a knife. Other parts of this vernier caliper is used for measuring narrow space, a distance of holes of eyeball, etc. Its main shortcoming is that because of thin edge of its jaw, it wears out quickly and starts giving inaccurate measurements. It should be used sparingly and carefully. The third one is flat and knife edge vernier caliper. Some companies also make vernier calipers which have their jaw like an ordinary vernier caliper from one side but have knife edge jaw at the other side, as shown in the figure. With this vernier caliper, all types of jobs can be measured easily. The fourth one is vernier gear tooth caliper. This is a special type of instrument which is made like a combined form of two vernier calipers. It contains two separate scales, vertical and horizontal, as shown in the figure. With the vernier caliper, the thickness of a tooth of gear can be taken form its pitch circle. In other words, the vernier caliper is used to measure different parts of gear. The fifth one is vernier depth gauge. This depth gauge is made of a thin beam like a narrow rule. Main scale and vernier scale are also in inch or metric system in it. As is evident from its name, this instrument is used for measuring the depth of the slat of a job, its hole or groove. This is almost similar to vernier caliper. Its reading is also taken in the same way. But instead of a jaw, a flat-shaped base is used as shown in figure. The sixth one is vernier height gauge. This type of vernier height gauge, there is no facility to set the beam or base according to the requirement of the job. In movable base vernier, this facility exists. This type of vernier height gauge is in the form of a set, which has a base vernier caliper, offset scriber, fixing screw, etc. All its parts have been shown in the figure. It is used for taking accurate measurement of height of a job or or for marking. It is almost similar to vernier caliper, but it is used for attaching some additional attachments. Beam remains fitted on a base in length form. Offset scriber is fitted on the beam itself, with which height of the job is measured or marking is done. Its bases are of two types: solid base and movable base. In vernier height gauge, the slide base remains joined with the beam permanently as shown. The last one is vernier dial caliper. Like vernier calipers, it can measure in inches as well as in millimeters. Like a dial test indicator, the rack and pinion are used in it. The rack remains on the main scale, which is connected to the pinion of the dial. For using it, movable jaw is moved by the thumb ruler. For taking a reading, we have to check how many main and sub marks are an inch the level edge of the movable jaw has crossed and added the reading. The needle on the dial give. So before we move to metric reading, we will watch two videos about application of vernier caliper and how to read a metric vernier caliper. So the first one is application of vernier caliper.
The vernier caliper is a precision instrument that can be used to measure internal and external distances extremely accurately. The example shown here is a manual caliper. The main scale has the normal resolution with a 1 division value is 1 mm. The vernier scale is attached with the main scale, which can slides on it and has 50 divisions on it. Other parts of vernier caliper are external jaws. These jaws are used for measuring external dimensions. Job is placed in between these jaws. Internal jaws are used for internal dimension measurement like washer internal diameter, groove, slot. Stem is used for depth measurement or height measurement. Lock screw is used for locking vernier scale moving body. List count is nothing but smallest possible value that can be measured using instrument. This can be calculated by smallest division value on main scale in millimeter divided by total number of division on main scale. Here in this case 1 mm is 1 division value divided by 50 numbers, which is total count of vernier scale line, is equal to 0.02 mm. So list count is 0.02 millimeter. The vernier scale works on the principle of using alignment of line segments displaced by a small amount to make fine measurements. Human eye can easily detect this alignment of line, which is the main fact that drives a vernier. Let's see how to use vernier caliper. Firstly, we need to place the job in between the external jaws. Close the jaws. By the combination of vernier scale and main scale, we can get measurement value. Main scale reading is the line which is left side of vernier scale 0. Vernier scale is line which is aligned or collinear with main scale line. Here in this case it is 37th line if we count from left side 0. If we put this value in formula, that is main scale reading plus vernier scale reading into list count, so we can get the final value, that is 60.74 mm. This is another example of external jaw. In this the value of main scale reading is 52 mm. and vernier scale reading value is 10 division. So final reading will be 52.20. Vernier caliper can be used for three types of measurements. First one is outside distances such as the length of the object. Second one is inside distances such as the width of the groove or keyways and diameter of large hole. Third one is depth such as the depth of hole or the height of the steps.
So the second video is learn how to read a metric vernier caliper.
Hi, I'm Bob Welts, and this is how to read a metric vernier caliper. There are different kinds of vernier scales designed to do different jobs, but they all work pretty much the same way. Today, we're going to look at a metric vernier designed to measure to the nearest 1/50th of a millimeter. That is 0.02 millimeters. See how 1 divided by 50 equals 0.02? Now, the first thing we're going to measure with our vernier caliper is nothing. That's right, we'll measure 0. It may sound like a silly thing to do, but we're going to do it for a couple of reasons. Let's do it and you'll see what I mean. You see, when the calipers are fully closed, measuring 0 width, you can see the places where you can take measurements. These surfaces are where the two parts of the calipers line up. You'll also notice there are gaps in a couple of places on the calipers. These are not places to take measurements, so don't mess up by putting something in one of those gaps. Now, with the calipers closed, you can see where you're supposed to read the main scale. There are two scales on a vernier caliper, the main scale and the vernier scale. I'm going to erase the vernier scale and let you just look at the main scale first. You see, the 0 mark points to the place where you're supposed to read the main scale. Right now it points to 0. Do you see that? Good. Let's read the main scale first. It's super easy. I'll close the calipers on this workpiece and we'll see what the main scale says. These marks represent whole millimeters. So the reading is 1, 2, 3, 4, 5 millimeters. Just be sure to look at the 0 mark and not at this part. That's a common mistake and it'll give you the wrong reading. So the reading is 5 millimeters. That's pretty easy, right? Before we move on to the vernier scale, let me show you what it's going to tell us, okay? Let's say when we looked at the main scale, the reading wasn't right on the mark like it was last time. Let's say it looked like this. See how the mark is between 5 and 6 millimeters? It looks like it's a little beyond halfway. You see, the vernier scale is going to tell us almost exactly how far over the mark is. Okay, you're ready to see the vernier scale, but I'm only going to draw the main part of it first. Now, you see the marks number from 0 to 10. Each of these marks represents a tenth of a millimeter. They're going to tell us the tenths of a millimeter, and here's how they work. Look carefully, and you will notice that one of the marks on the vernier scale lines up better with the main scale marks than the others. Which one looks like it lines up best to you? I'll zoom in and let you look. Let me show you a hint about where to look on the vernier scale to see where the marks line up. You see how our pointer was a little more than halfway between marks? That means the vernier scale will line up a little past halfway. Now, do you see the mark that lines up better than the rest? It looks like the 7 is lining up. The 7 means 0.7 millimeters. But this caliper can measure even more accurately than that. I'll redraw all the marks and let you look again. Now, see that the mark next to the 7 lines up best. But what is the value of that mark? Remember how this caliper had a label that said 0.02 on it? That is what each mark is, 0.02 millimeters. Let's count up on the vernier scale to be sure we've got it. This 6 would be 0.60, the next mark 0.62, then 0.64, 0.66, 0.68, 0.70, then 0.72. The reading is 5.72 millimeters. Pretty neat, huh? I'm going to let you try a few. We're going to start off easy. I'm going to draw a caliper that only reads to the nearest tenth of a millimeter, just to be sure you're with me. I'm going to show you the overall picture first, then zoom in to let you see the vernier better. Okay? When you see Sparky's pause the video and write down what you think the reading is. The reading is 16.2 millimeters. Let me step you through it just in case you missed something. Here are the whole millimeters from the main scale. 10, 11, 12, 13, 14, 15, 16. Okay. And you see how the reading is just past the 16 mark? So we'll look to the front of the vernier scale for where the marks line up. And there it is, at the 0.2 mark. So the reading is 16.2 millimeters. Got it? Okay, let's go for broke and see if we can read the full 0.02 millimeter resolution. Ready for this one? Again, I'll show the whole caliper, then zoom in to let you see the vernier better. Here we go. Pause the video and write down your answer. Now, I know this is hard, so before I give the answer, I'm going to point to the place where the vernier lines up. Does that help? Take a minute and check your answer and be sure it's correct. The reading is 19.16 millimeters. Okay, let's try another one. This time I won't give any hints, but I will zoom way in so you can see the calipers really well. If you get this one, you pretty much know what's going on. Pause the video and make sure you can read the whole millimeters. Did you say 12 millimeters? Okay, let's do the hard part and read the vernier scale. I'll zoom in and let you take a closer look. But first, remember the trick? See how the reading is beyond halfway between the marks? That means we need to look on the high side of the vernier scale. I'll slide the view down there and let you look. Now here we go. Pause the video and look carefully. The mark that lines up best is here. Now, what number is that? This is the 0.7 mark. So 0.7246. The answer is 12.76.
So that is the end of the video. So now, let's proceed to metric reading. To read a metric ruler, each individual line represents 10 or 1 divided by 10 of centimeter or 1 millimeter. Notice when converting from centimeters to millimeters, the decimal point is moved from one place to the right. To convert millimeters to centimeters, move the decimal point one place to the left. So if you want to convert centimeters to millimeters, you move one place to the right. Then if you want to convert millimeters to centimeters, you move one point to the place to the left. So karon atong kuhaon ang least count sa 0.02 with 50 division. Ang formula na imong gamiton is to get the least count is main scale division divided by vernier scale division. So 1 divided by 50. So ang 1 ato siyang nakuha sa smallest division sa main scale, which is 10 divided by 10 equals 1. Tas ang 50 ato siyang nakuha sa total number of division sa vernier scale. So, imo na siyang i-divide. Ang mugawas na answer is 0.02, which is ang least count. Example number 1. Ang vernier caliper has two scale. These are the main scale and the vernier scale. Ang main scale, imong makita sa upper part, which is the color black one. Kanang color itom, nga nasa upper part. Then, ang vernier scale, which is in the lower part, which is in the color blue. Kananas ilalom. So, the formula to get the final reading is main scale plus Vernier scale. So, by the way, this is the example of direct reading. So, ako po yun yung ipakita ninyo ang example sa indirect reading. So, atong kuhaon una ang graduation gikan sa 0 hangtod sa 1. So, ang iyang graduation is 10. So, ang value niya kada guhit is 1 millimeter. So, atong kuhaon ang iyahang main scale. Atong ihapon ang iyahang kada guhit. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, ang iyahang main scale is 9. Kay ang 0 sa Vernier scale, natupong siya sa tungaan in between sa 9 ug 10. So, mas pabor man siya sa 9. So, maong ang iyang Vernier scale, ang iyahang main scale is 9. So, atong kuhaon na pod ang iyahang Vernier scale. So, ang value sa kada guhit sa Vernier scale is 0.02 mm. Then, ang pagkuha sa Vernier scale or ang iyang pag-read is lantawon nimo ug asa siya natupong or ni-coincide. So, atong ihapon ang iyahang kadaguhit ug asa siya natunong. Atong lantawon pod ug asa siya natunong. So, atong ihapon ang kadaguhit. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Since sa 32 man siya ni coincide or ni tupong, so ang iyahang Vernier scale is 0.32. So 9 plus 0.32 equals 9.32 mm, which is ang ato ang final reading. Let's proceed to example number 2. Same lang gyapon sa example number 1. Atong kuhaon ang iyahang main scale. So, i-count na to ang kada guhit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, ang iyang main scale is 16. Kay ang 0 sa Vernier scale, nagtupong siya in between sa 16 to 17. So, mas pabor man siya sa 16. So, maong ang iyang main scale is 16. Then, atong kuhaon ang iyahang Vernier scale. I-count na to ang kada guhit. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. So, ang iyahang Vernier scale is 50. Kaya ang 50 nitupong siya, diha siya ni coincide sa 50. So, 15 plus 0.50 equals 15.50 mm, which is ang ato ang final reading. Example number 3. Atong ihapon ang kada guhit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Ang iyahang main scale is 23. Kay ang 0 sa Vernier scale, nitupong siya in between sa 23 ug 24. So, ang ato ang main scale is 23. So, atong kuhaon ang ato ang Vernier scale. So, mag-count. Atong i-count ang kada guhit. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Since sa 24 man sila nagtupong or ni-coincide, so ang iyahang Vernier scale is 24. So, atong i-plus. 23 plus 0.24 equals 23.24 mm, which is ang ato ang final reading. So, let's proceed to 0.02 with 25 division. Same lang gyapon ang formula. Main scale division divided by Vernier scale division. So, ang 0.5 divided by 25. Ang 0.5 ato siyang nakuha sa smallest division sa main scale, which is 10 divided by 20 equals 0.5. Then, ang 25, total number division sa Vernier scale. So, imong divide. Ang answer is 0.02, which is ang atong least count. So, mo ni siya ang example sa indirect reading. Imuha siyang i-times og 0.02. So, atong kuhaon ang iyahang graduation. So, ang iyahang graduation gikan sa 0 hangtod sa 10 is 20. So, ang iyahang value kada guhit is 0.5. So, atong i-count ang kada guhit para makuha na to ang main scale. So, 0.5, then 0.5 plus 0.5 equals 1. Imuha lang siyang i-plus. So, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So, ang iyang main scale is 6. Kaya ang 0 sa Vernier scale is in between siya sa 6 o sa 6.5. So, mas pabor man siya sa 6. So, ang iyahang main scale is 6. So, ato na pong kuhaon ang Vernier scale. So, atong ihapon ang iyahang kada guhit. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, ang iyahang Vernier scale is 13. Kay nitupong ni-coincide siya sa 13. Since indirect reading man ni siya, ato siyang i-times og 0.02. So, 13 times 0.02 is 0.26. So, 6 plus 0.26 equals 6.26 millimeter, which is ang atong final reading. Example number 2. atong kuhaon ang iyahang main scale. So, same lang gyapon, i-count na to ang kada guhit. So, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10. Tas 10.5, then 10.5. So, ang iyahang main scale is 10.5. Kay ang zero sa Vernier scale is in between sa 10.5 to 11. So, mas pabor man siya sa 10.5. So, ang iyang main scale is 10.5. So, atoa na pong kuhaon ang iyahang Vernier scale. So, ihapon na to ang kada guhit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, sa 19 siya ni coincide. So, ang iyahang Vernier scale is 19. Since indirect man siya, so ato siyang i-times og 0.02. 19 times 0.02, ang answer is 0.38. So, 10.5 plus 0.38 equals 10.88 millimeter, which is ang atuang final reading. Example number 3. Same nagyapon, ihapon na to ang kada guhit. So, ang number of valued kaning, so ihapon na to sa 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15.5, 16. So, ang atuang main scale is 16. Then, atuang kuhaon ang atong Vernier scale. Atong i-count ang kada guhit. 1, 2, 3, 4. So, sa 4 man siya ni coincide, ang atuang Vernier scale is 4. Ato siyang i-times og 0.02. 4 times 0.02 equals 0.08. So, 16 plus 0.08, ang answer or ang final reading niya is 16.08 millimeter. Kulang lang siya og 0. So, let's proceed to next example. So, another So, 0.05 with 25 division. Same lang gyapon. Main scale division divided by Vernier scale division. So, 1 divided by 20 equals 0.05, which is ang atuang least count. Example number 1. So, this is another example of direct reading. So, ang iyahang graduation is 10. So, ang number or ang value niya kada guhit is 1.1 millimeter. So, atong kuhaon ang main scale. Atong i-count ang kada guhit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, ang atong main scale is 14. Kaya ang 0 sa vernier caliper ni tupong siya ay nasa in between sa 14 and 15. So, mas dual man siya sa 14. So, ang atong main scale is 14. So, ang atong kuhaon na pod ang iyahang vernier scale. Ang value sa kada guhit sa vernier scale aning niya is 0.05. So, atong i-count ang kada guhit. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So, sa 55 man siya ni coincide or ni tupong, so, ang atong vernier scale is 55. So, atong i-plus. 14 plus 0.55 equals 14.55 millimeter, which is ang atong final reading. Example number 2. Same lang gihapon. Atong ihapon ang kada guhit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So, ang ato ang main scale is 22. Ang ato na pong kuhaon, ang ato ang vernier scale. Ihapon nato. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So, sa 65 man siya ni coincide or ni tupong, so, ang atong vernier scale is 65. So, atong i-plus. 22 plus 0.65 equals 22.65 millimeter, which is ang atuang final reading. Example number 3. Atong ihapon. 1, 2, 3, 4. Ang atong main scale is 4. Next is ang vernier scale. Atong ihapon. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So, sa 80 man siya ni tupong or ni coincide, ang atong vernier scale is 80. So, atong i-plus. 4 plus 0.80 equals 4.80 millimeter, which is ang atuang final reading. So, let's proceed to 0.04 with 25 division. Same lang gyapon ang pagkuha sa list count. Main scale division divided by vernier scale division. 1 divided by 25 equals 0.04, which is ang atuang list count. So, another example of indirect reading. So, ang iyahang total graduation is 10 from 0 to 10. Ang iyahang number or value kada guhit is 1 millimeter. So, atong kuhaon ang main scale. Atong ihapon. 1, 2, 3, 4, 5, 6, 7, 8. So, ang atong main scale is 8. Kaya ang 0 sa vernier caliper, natunong siya in between sa 8 and 9. So, mas duol man siya sa 8. So, ang iyahang answer or ang atong main scale is 8. So, next is ang atuang vernier scale. Atong i-count ang kada guhit. 1, 2, 3, 4, 5. So, 5 ang atuang vernier scale. Since indirect man siya, ato siyang i-times og 0.04. So, 5 times 0.04 5 times 0.04 equals 0.2. So, 8 plus 0.2 equals 8.22 millimeter, which is ang ato ang final reading. Example number 2. Same lang gyapon, atong i-count ang kada guhit sa main scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, ang ato ang main scale is 16. Ang atong vernier caliper, vernier scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, sa 16 man siya ni coincide. So, ang ato ang vernier scale is 16. Ato siyang i-times og 0.04. So, 16. So, ang iyahang answer is 0.64. So, 0.64 equals 16.64 millimeter, which is ang ato ang final reading. So, example number 3. Count na to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So, ang ato ang main scale is 22. Ang atong vernier scale, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, ang ato ang vernier scale is, 17. Kay sa 17 siya ni coincide or ni tupong. So, ato siyang i-times og 0.04. So, ang answer niya is 0.68. So, 22.0.68 equals 22.68 millimeter, which is ang ato ang final reading. So, that's the end of my presentation. Thank you, and I hope you understand.